Mid-April 1943. Tunis, Tunisia. The captured Tiger I heavy tank rolled to a stop on a ruined Tunisian street, its German Balkan cross markings still clear on the gray paint. British, American, and French Army engineers and intelligence officers gathered around the prize, notebooks in hand. This was a unique Tiger I, captured nearly intact and in running order after the Battle of El Guatar, and it would pose a profound conundrum for Allied engineers, one that would echo through their tank development programs for the rest of the war. The rules of armored warfare were about to be rewritten, not through mechanical innovation or mass production, but through something the Germans had prioritized above all else: overwhelming power and relentless technical complexity. The tank bore the serial number 250012, built by Henschel und Sohn, and belonging to the 3rd Company of the 501st Heavy Panzer Battalion. Personnel from a British Army unit operated this tank for the short distance over North Africa's rugged terrain to the port of Tunis, a brief but eventful journey. Every kilometer revealed something that reinforced Allied assumptions about German industrial capabilities. The engine frequently overheated, the transmission periodically malfunctioned, the final drives groaned alarmingly. Allied tank crews accustomed to the relative reliability of the Sherman watched with growing unease as this enemy vehicle struggled with a myriad of problems over terrain and conditions it should have easily traversed. At the port, the Tiger was loaded onto a cargo ship bound for Britain. The British War Office intelligence issued clear orders. This tank had to reach the testing facility at Chobham intact and operational. Allied intelligence had received fragmented reports on German heavy tanks, but seeing the actual vehicle brought the statistics to life in a way that numbers on a page never could. The Tiger I represented a design philosophy that prioritized power and complexity above all else, built with engineering principles that Allied engineers found difficult to comprehend in terms of combat serviceability. As the ship moved north through the Mediterranean, British military engineers prepared testing protocols that would reveal truths they had been reluctant to face about German engineering capabilities and its inherent weaknesses. Summer 1943, at the Chobham Proving Grounds, Surrey, England. The Tiger I rolled off its transport flat car, bearing the designation Tiger 131 and its British inventory markings. Test engineers had already painted armor thickness and angle measurements on every surface of the tank, marking it with precise notations for their comprehensive evaluation program. The British Army's proving grounds at Chobham served as the primary testing facility for both British and captured enemy equipment. Here, meticulous engineers measured, tested, and analyzed everything from track tension to gearbox performance, recording their findings in exhaustive technical reports. The Tiger was about to undergo the most comprehensive mechanical examination Allied engineering could devise. The British test engineers conducted initial inspections with specialist teams from various engineering disciplines. They photographed every component from dozens of angles, measured every tolerance with precision instruments, and documented manufacturing techniques that seemed impossibly complex compared to Allied methods. The transmission system immediately drew the attention of powertrain specialists. While Allied tanks used simpler, more easily manufactured and maintained solutions, the Tiger employed an 8-speed, semi-automatic Maybach OVAR transmission, an engineering marvel of multiple spur gears that required extremely precise tolerances and constant maintenance. This design, while theoretically impressive, was considered far too difficult to mass produce, and especially to repair under field conditions. Allied engineers had deemed such spur gears and complex control systems too difficult to manufacture at scale with their industrial capacity, and nearly impossible to maintain without factory-level specialists. The Germans had produced them, but at the cost of reliability and manufacturability. The trials began with basic automotive tests designed to stress every mechanical system under controlled conditions. Engineers drove Tiger 131 over obstacles designed to simulate battlefield conditions, measuring fuel consumption, monitoring engine temperatures, and recording gearbox behavior under various loads and terrain. After each trial, they disassembled components to check for signs of wear. looking for evidence of stress, inadequate lubrication, or design weaknesses. The results reinforced everything Allied tank doctrine had embraced about the necessity of balancing performance with reliability. The Tiger performed impressively in certain categories, such as engine power and gradient climbing, but failed spectacularly in the metric where Allied tanks consistently excelled: operational endurance without maintenance intervention. The examination of the powertrain revealed differences in design philosophy that explained much about the German versus Allied approach. The Tiger's gearbox had 8 forward gears, plus 4 reverse, operated hydraulically and pneumatically, requiring a highly skilled driver and frequent complex adjustments. This made the tank incredibly difficult to drive compared to Allied tanks, demanding specialized and continuous driving training. Allied tankers, in contrast, spent less time learning complex driving techniques and could focus more on combat. The Tiger's design assumed that highly trained specialists would be available to operate and maintain these machines, while Allied design accepted that ordinary soldiers with basic automotive knowledge would operate them. The Tiger's Maybach HL230 P45 V12 engine in this particular tank proved remarkably sensitive to varying operating conditions. Engineers noted that the engine struggled to maintain consistent performance across temperature ranges that Allied engines would have handled easily without overheating or losing power. The cooling system, while intricate in its design, proved inefficient. The air filtration system struggled to handle desert sand, leading to frequent clogging, a critical issue for German tanks in North Africa. Every system reflected a design philosophy that prioritized theoretical sophistication and overwhelming power over practical function and maintainability. August 1943, at the Lowell Cove firing range, a major armaments conference was held, attended by leaders from the armaments industry and senior British and American Army officers. The demonstration program included comparative trials between Allied tanks and the captured Tiger I. Tiger 131 stood alongside the latest Allied designs, including an M4A2 Sherman and a Churchill Mark VII, representing the most advanced Allied armored fighting vehicle technology. Allied leaders responsible for arms production and reporting results to their superiors needed to understand what German industry could produce and where Allied designs stood in comparison to enemy equipment. The demonstration would provide answers that Allied tank designers were relieved to acknowledge. The Tiger powerfully ascended the test slope with its 88mm gun pointed majestically skyward. However, its complex semi-automatic transmission frequently stalled as the driver attempted to shift under heavy load. Its engine, though powerful, showed signs of overheating and failed to maintain consistent power throughout the climb. The driver handled the vehicle with visible caution, demonstrating the operational difficulty that had become a hallmark of the Tiger. The Sherman and Churchill followed, their reliable engines allowing them to match the Tiger's performance, but with considerably more ease and without any malfunctions.
Years later, Allied experts would write about the Tiger's capabilities they observed in analytical reports. They noted that reports of the Tiger's cross-country mobility were often hampered by mechanical issues, with the tank struggling on rough terrain that Allied tanks traversed with ease. They attributed this to the Tiger having an engine that was overworked for its enormous weight, giving it cross-country mobility on flat ground that was not truly superior to Allied tanks, and actually inferior when the terrain became difficult. The British 7th Armored Division specifically reported on these weaknesses. These observations from Allied defense ministers carried significant weight in military circles. A public written assessment appeared in Allied newspapers in September 1943. The articles described the Tiger as a monster of power and armor thickness, but also noted its complexity and low reliability. The articles referred to the complex suspension with its overlapping road wheels as an engineering feat but a maintenance nightmare, acknowledging German innovation in this area. These public statements, carefully worded for morale-boosting propaganda purposes, nevertheless concealed the private concerns spreading through Allied engineering offices. German tanks were not just a threat, they were an example of a fundamentally different design philosophy. Back at Chobham, systematic testing continued through the summer of 1943 and into the fall of 1943. Engineers measured the Tiger's operational range, conducting extended trials that pushed the vehicle to its limits. They recorded an operational range of under 100 kilometers before major maintenance was required, a fraction of what Sherman models could achieve under field conditions. They measured a drivetrain efficiency worse than any Allied tank, with power losses through the transmission significantly higher than in comparable Allied systems. They examined the complex semi-automatic gearbox that demanded careful shifting and constant adjustment, frequently causing driver error and damaged components. The Tiger's final drives presented another disappointment that challenged Allied engineering assumptions. German Tiger tanks used a final drive system designed to transmit the immense torque from a 700 horsepower engine to the tracks, a configuration prone to failure under stress. The design used spur gears in housings that proved inadequate for the loads imposed by the 57-ton vehicle. German mechanics in North Africa and on the Eastern Front reported frequent final drive failures, forcing Tigers to be abandoned after relatively short road marches, sometimes less than 50 kilometers. The Sherman's final drives, built with the same herringbone gear principles as its transmission, rarely failed, even under prolonged combat conditions that would have destroyed the German components. By late 1943, Chobham had accumulated enough data to produce comprehensive internal reports circulated within Allied engineering branches. These documents, intended for senior Army officers and Ministry of Defense officials, painted a sober picture of comparative capabilities. The Tiger demonstrated a German engineering sophistication that the Allies, despite their theoretical knowledge and scientific expertise, had deliberately avoided for practical reasons. Complex manufacturing techniques demanded extremely precise tolerances and high skill, resulting in less reliable vehicles that performed poorly under field conditions. Non-interchangeable parts meant that field repairs could not be performed without specialized tools and highly specific training. Whereas Allied practice prioritized keeping vehicles running, German design assumed factory-level maintenance and highly qualified specialists would be available. Allied internal technical assessments documented observations of German industrial advantages that went beyond mere production numbers, but also of its costs. German automotive engineering reflected a focus on complexity and peak performance that Allied civilian industry had never developed on a comparable scale. Before the war, the United States had a massive number of car owners, with vehicles common among ordinary citizens of all economic classes. Germany had far more limited civilian automotive experience, with cars remaining luxury items for the wealthy and the party elite. This vast difference in automotive industry maturity translated directly into tank design philosophy. The Americans and British built tanks that mechanics with civilian automotive training could maintain with the skills they already possessed. The Germans built tanks that required specialized training and the constant attention of experts with years of specific military technical education. The comparison with German tank reliability became impossible to ignore as field reports accumulated in late 1943 and early 1944. Tiger tanks required strict operational restrictions to prevent mechanical failures that could leave them stranded. Drivers received explicit instructions to handle the complex transmission carefully to avoid damaging it. The final drives failed so frequently that field manuals warned against moving too fast or too far. The Tiger could not execute a pivot turn on hard ground because this would destroy the transmission or final drives, severely limiting tactical flexibility. Foreign objects entering the running gear could jam the overlapping road wheels, requiring hours of maintenance to clear. These problems existed despite the Tiger being built in dedicated tank factories by skilled workers using the best materials Germany could provide. On the contrary, the Sherman had been designed by automotive engineers at General Motors, Ford, and Chrysler, applying the principles of mass production they had developed over decades of civilian vehicle manufacturing. The tank incorporated commercial automotive parts wherever possible, taking advantage of existing supply chains and production expertise. Drivetrain components came from multiple manufacturers, all building to identical specifications with parts that were fully interchangeable and could be mixed freely without adjustment. This standardization, which was common practice in the American automotive industry, remained largely theoretical in German tank production, where each manufacturer introduced subtle variations that prevented full parts interchangeability. Additional captured Tiger tanks arrived at Chobham throughout 1943 and 1944, including tanks taken from German units in Italy and German forces on the Eastern Front. Each captured vehicle underwent the same testing protocols, building a comprehensive database of German tank capabilities across different variants and production periods. The automotive testing program was expanded to include reliability trials specifically designed to replicate combat conditions. Engineers drove Tigers over dozens of kilometers of cross-country movement, documenting every mechanical failure, maintenance requirement, and component breakdown. They compared these results against field reports from Allied Sherman and Churchill units operating on the Eastern Front and in Italy. The numbers told a clear story of relative reliability. The Tiger's operational readiness rate averaged below 30% for most of 1943, with some units reporting disastrous rates of just 10 to 15%. Individual Tiger battalions recorded periods where less than 1 in 10 tanks were actually capable of combat operations. In contrast, Allied tanks maintained significantly higher operational readiness on all fronts. Specific data from German field reports, which Allied intelligence acquired, documented the Tiger's reliability problems in devastating detail. In July 1943, during Operation Citadel at Kursk, the Tiger achieved a low operational readiness rate, with mechanical failures taking out more tanks than enemy action. By December 1943, readiness remained low. These numbers represented the percentage of Tigers actually capable of combat operations on any given day, with the remainder broken down, awaiting parts or undergoing repair. The progression showed minor improvements as design flaws were addressed, but even the Tiger's best readiness rates never matched what the Sherman achieved. By December 1943, the pattern had become undeniable to any objective observer reviewing the data. The Tiger's engine life rarely reached 500 kilometers under combat conditions. The Sherman's engine achieved over 3,000 kilometers. The Tiger's transmission required constant attention and frequent repairs, with failures so common that drivers had to avoid using certain gears. The Sherman's transmission required minimal maintenance. The Tiger's final drives proved unreliable under conditions where the Sherman's final drives performed well. Field reports from Allied units facing the Tiger reinforced the Chobham test data with real operational experience. Allied infantry and armored units learned that it was not uncommon for a Tiger to break down on the battlefield. Unlike repairing a Sherman, repairing a Tiger in the field was a major effort, often requiring specialized recovery vehicles and many hours of labor. Allied tankers took comfort in knowing that even if they couldn't knock out a Tiger, there was a good chance it would disable itself with mechanical problems. Allied commanders recognized what the Chobham tests had proven. German tanks, however powerful, could not be relied upon to function when needed. This unreliability, regardless of firepower or armor protection, determined their tactical usefulness. A Sherman that reached the battlefield with a working gun was infinitely more valuable than a Tiger with superior firepower that had broken down 20 kilometers from the front line. January 1944 brought expanded testing programs as Allied forces advanced on multiple fronts and additional captured German equipment arrived at Chobham. Engineers examined other variants of the Tiger, documenting their characteristics. Each variant displayed the same fundamental trait: poor mechanical reliability stemming from complex engineering principles and demanding production processes. The lack of consistency between variants struck Allied engineers, who were accustomed to the high degree of standardization in their own production.
Reports from Allied commanders noted in official communications that Tigers, while a threat, were limited by their poor reliability. Although Germany attempted to improve reliability, the fundamental problems remained. This improvement, though presented as a significant success in German military communications, which the Allies acquired, merely brought the Tiger's reliability to a level that Allied tanks had surpassed from the beginning. The German army celebrated achieving standards that Allied tanks had long exceeded, highlighting Germany's misplaced focus in armored vehicle development. The comparison became even starker as German tank production struggled with increasing resource shortages and Allied strategic bombing. Allied bombing campaigns targeted critical bottlenecks in the Tiger production chain with increasing effectiveness. The Maybach engine factory and the German ZF gearbox plants suffered heavy damage. The production of tank engines and transmissions was completely disrupted. When production eventually resumed, quality control had declined significantly. Forced labor, increasingly used in German tank factories as German workers were conscripted, engaged in deliberate acts of sabotage. These problems never affected Allied tank production, which was safely located in Allied factories far from any combat zones and staffed by a motivated, well-paid workforce under good conditions. The fundamental difference between Allied and German tank production was not in technical knowledge, but in industrial capacity and underlying design philosophy. German engineers understood automotive principles as well as their Allied counterparts, possessing extensive theoretical knowledge and scientific expertise. They simply applied those principles differently to tank design, prioritizing different factors. German tanks emphasized performance characteristics that made for impressive specifications but had poor reliability under field conditions. The Tiger's powerful 88mm gun and thick armor came at the cost of an overstressed powertrain and final drives that could not reliably support the vehicle's 57-ton weight. The Tiger's formidable capabilities required complex maintenance procedures and frequent repairs by highly trained specialists. These trade-offs might have been acceptable if German industry could have produced enough vehicles and enough spare parts to maintain them. But they could not, especially as Allied bombing intensified and raw material shortages worsened. Allied engineers schooled in automotive mass production through decades of civilian industry experience designed tanks that could be manufactured in the tens of thousands and maintained by basically trained mechanics using skills learned in civilian life. The Sherman and Churchill's powertrains used components that were proven in commercial service, with design principles borrowed directly from car and truck manufacturing. The electrical systems included simple but effective features, which German designers had not prioritized over armor and firepower. Allied tankers could enjoy such amenities, especially those who had witnessed the problems with German tanks. These features did not appear in German specifications because German designers did not consider them a top priority compared to armor thickness and gun power.
By the spring of 1944, Wehrmacht units on all fronts were reporting increasing mechanical problems as production quality declined and spare parts became scarce. The Tiger required rail transport for movements exceeding a few dozen kilometers because their final drives could not survive sustained long-distance road marches. Field commands issued explicit orders restricting Tiger movements to conserve the vehicles for actual combat rather than losing them to mechanical failure during approach marches. German recovery vehicles, often built on captured tank chassis or heavy-duty trucks, shared the same reliability problems as the tanks they were supposed to rescue. German commanders faced the grim reality that mechanical failures were taking out more tanks than enemy action. Meanwhile, Allied tank production continued at a pace that German industry could never match. American factories produced tens of thousands of Sherman tanks during the war, more than the total German tank production of all types combined. The British Commonwealth produced thousands of Churchill and Cromwell tanks. Every battlefield where Allied tanks served confirmed what the Chobham tests had revealed. Properly maintained Shermans and Churchills kept running under conditions that would have crippled or destroyed German tanks. Allied tank crews faced and learned to fight the Tiger and recognized its inherent weaknesses. Reports from the Eastern Front noted that Allied mechanics found German tank engines complex to the point of being difficult to troubleshoot compared to Allied tank engines. The Tiger's Maybach engine required constant adjustment of valve clearances, ignition timing, and carburetor settings. The Tiger's design limits, while impressive in their load-bearing capacity, lacked the flexibility that Allied engineers had integrated into their designs. The Tiger's basic powertrain and gearbox components were specified for its 57-ton vehicle, but without much margin for future upgrades without a complete redesign. By the summer of 1944, Allied tank commanders advancing into Normandy knew that their engineering advantages went far beyond the capabilities of individual tanks. Allied artillery superiority, devastating close air support, and overwhelming logistical capacity combined to overpower German forces, regardless of tank specifications or tactical talent. But the reliability of the Sherman and Churchill meant that Allied armored units could sustain continuous operations that German panzer divisions simply could not match. Allied tank battalions could launch attacks, sustain combat operations, conduct pursuits, and immediately prepare for the next operation without needing to stop for extended maintenance. German panzer divisions had to carefully manage their limited number of operational vehicles, calculating that every movement consumed precious remaining component life and brought mechanical failure closer. The difference in operational readiness determined which force could maintain offensive pressure and which had to carefully ration its limited combat power. The Allied encounter with the Tiger in combat operations provided the final proof of German complexity and poor reliability from the Allied perspective. German plans for infiltration operations were often thwarted by the poor reliability of their vehicles, unlike the Allies with their dependable vehicles. German tanks, even when fully operational, could not guarantee the sustained performance that such missions required. On January 23, 1945, there were final reports from Allied commanders on the state of German armored forces. The findings of the intelligence documents were devastating. Catastrophic final drive failures on all types of German tanks continued. Allied commanders understood the operational impact of these problems. Under such circumstances, the orderly employment of tanks was simply impossible. The German army lost faith in their vehicles and often abandoned entire vehicles for mechanical issues alone, fearing they would become stranded and captured. German tanks, built to inspire fear through impressive specifications, had failed at the most basic requirement of an armored vehicle: sufficient mechanical reliability to reach the battlefield and accomplish the mission. The Chobham testing facility prepared for post-war document analysis as Allied forces advanced relentlessly toward Germany. Engineers reviewed the test data and captured documentation from German facilities, hoping to synthesize technical intelligence for post-war analysis. Captured German tanks provided a final comparison under real combat conditions. Tigers and Panthers continued to fail from mechanical breakdowns at a rate that shocked even seasoned crews accustomed to poor reliability. The story of Tiger 131 and the dozens of other Tigers tested at Chobham represents one of the great industrial disparities of World War II. German engineers working within an industrial system that prioritized theoretical perfection and peak performance over practicality produced tanks that looked impressive on paper but failed in sustained field operations. Allied engineers, applying decades of automotive manufacturing experience to military requirements, produced tanks that may have lacked engineering sophistication in many areas, but performed reliably under the conditions that defeated German equipment. In armored warfare, as in most military operations, the weapon that works when needed will defeat the weapon that might theoretically outperform it if it could reach the battlefield and accomplish the mission. Post-war analysis by American and British intelligence organizations confirmed what the Allied tests at Chobham had revealed. Systematic examination of knocked-out German tanks showed that mechanical failure was as common as combat damage as a cause of loss. Final drives fractured under stress, transmissions seized from inadequate lubrication or operator error, engines burned out from overheating or lack of oil.
The German obsession with individual vehicle superiority and impressive specifications had blinded them to the vital importance of reliability and maintainability. They had built tanks that no conscript mechanic could maintain without intensive training, powered by engines that demanded the constant attention of skilled technicians, supported by a logistical system that collapsed under the cumulative strain of supplying countless unique parts to scattered units.
The lessons learned through the Chobham tests directly influenced Allied post-war tank design thinking. As Western nations began developing main battle tanks in the 1950s, designers consciously emphasized reliability and maintainability over pure specifications. They studied American automotive engineering principles and deliberately applied them to military vehicle development. The result was tank designs like the Leopard 1 and M60 that incorporated many of the design philosophies that had made the Sherman successful. Robust powertrains with significant design margins, ease of maintenance requiring minimal specialized tools, standardized components that allowed for quick field repairs, and growth potential that allowed for future upgrades without complete redesigns. Tiger 131, the unique Tiger I tank captured in Tunisia and extensively tested at Chobham for months, told the entire story through its mechanical complexity and inconsistent performance. Every kilometer it ran with problems was proof that German tank design had taken a fundamentally wrong path in prioritizing specifications over reliability. Every test demonstrating German engineering complexity was proof that theoretical sophistication and an unrealistic will to pursue engineering perfection led to significant difficulties in production and maintaining operations in combat. Every comparison between the reliability of the Tiger and Allied tanks proved that the Germans had created problems that Allied engineers had deliberately avoided. The tank itself was beyond question in its power and armor, one of fewer than 1,350 produced. But what it represented was deeply damaging to German confidence, proof that Germany was losing the industrial war, even as the fighting continued, and that Allied production capacity could not be matched regardless of German technical sophistication or tactical skill. German tanks, especially the Tiger, consistently failed this basic test throughout the war. Allied tanks consistently passed it. The Chobham tests proved this beyond any doubt by mid-1943, even as German commanders continued to deploy Tigers that looked fearsome and possessed impressive specifications but could not be relied upon to function when needed most. The Tiger tank did not win World War II through technical superiority in firepower or armor protection. It failed because of mechanical complexity, poor reliability, and maintenance difficulties. Allied engineers at Chobham understood this by mid-1943 based on their comprehensive tests. They wrote detailed reports documenting their findings. They checked the evidence repeatedly with scientific rigor. They reached the correct conclusions about German weaknesses. But understanding a problem and solving it are entirely different challenges. German industry lacked the capacity to simplify production and focus on reliability principles, while simultaneously fighting a losing war on multiple fronts against enemies with superior resources. Allied industry had built reliability into its civilian automotive sector over decades of commercial competition and simply extended those mature principles to military production with remarkable success.